Okay, so today we talk about topic called namespace, and we'll discuss about the services. Okay, so in the meantime, what I'll do, I'll create a cluster, and then we'll discuss theoretically about namespace until it creates the cluster. And then we can do practical. So, are you guys doing practice whatever we discussed till in the last class?
Yes, perfect. Great.
So, anybody have idea about what is namespace?
Praveen, it's like one logical isolation entity on top of the Kubernetes, where you can deploy your Kubernetes resources.
Okay,
It's an object.
object. Okay, so it's getting created. So let's discuss about namespace. Okay, if you go and search for theoretical, it is. So namespaces are Kubernetes objects which partition a single Kubernetes cluster into multiple virtual clusters. So each Kubernetes namespace provides the scope for Kubernetes names it contains, which means that using the combination of an object name and a space. So I'm not sure how many of you understand this. So let me explain in a detailed way. See, in Kubernetes, we have a concept of namespace. So we have a lot of objects inside the Kubernetes, like pods are there, deployments are there. We discussed, right? Like we were talking about, for example, pod. If you create replication controller, RC, stateful set deployment, daemon and Z, and apart from this, lot of other objects is also there. Okay, like service, like whether it's a load balancer or cluster IP or node port or volumes or jobs, config maps, secrets. Okay, so these are the some of the objects we have in the Kubernetes. Many more objects are also there. Now all these objects we are going to create inside the default namespace. So we have a different namespaces will be available. So first of all, what is this namespace? Namespace is like a virtual cluster, which means, for example, your application is having 15 microservices. Means to run your application completely, maybe your complete website to run, assume 15 microservices are there. So each microservice you are going to deploy inside the cluster. Okay, so you have assume three worker nodes, and inside these three worker nodes, you are deploying your application. So for first microservice, when you are deploying, maybe each microservice is dependent on multiple objects of the Kubernetes. Maybe if it is a stateful application, then it's need a volume. So in the configuration file, in the deployment configuration file, you need to define about the volume also. And apart from that, you need to have config maps. Okay, what is config maps? Config maps is a object which we use for an application to mention the properties of that application. So properties means what? See, this database want to connect to some other application pod. There should be communication between these two. So this database should have the details of this specific application details, maybe IP and port number, or maybe this application want to connect to this database, then it should have the database name, port number, username, password, everything should be available inside the properties file. So by using that properties file, it will go and connect to this database. So this properties file we can have inside the config maps. Okay, so that is one of the object inside the Kubernetes. So that need to be provided for this application. So config maps, volumes, secret. What is secret? Secret, like Ansible Vault, and Docker also is having secret. So what it contains, you are encrypting the credentials. Okay, basically it will not encrypt, it's an encoding. So when you are providing the credentials, like I said in the config maps, you will provide the credentials to go and connect here, but only for specific credentials you can use secrets, so that it will use as an encoded credentials to go and connect to the database. Remaining all the properties like port number, IP of the database, all these things will be defined in the config maps, but it's in the plain text. So that's why we don't provide credentials inside the config maps. Credentials can be provided in the secret, and that secret we will define inside the application YAML file. So that is also one of the object. So like this, one microservice may be using multiple objects to run. So all these objects need to be created. So here, when this is a cluster when we are getting created, assume you deployed all these 15 microservices, and this is called as an dev environment. So all the 15 microservices have been deployed, and respective objects is also has been deployed. Now you want another environment called staging environment. For staging environment, again what you need to do, you need to create a new cluster. New means new physical infrastructure you need to create, whether it's in a Kuberium concept or whether it's in Google Cloud, GKE, whatever it may be. So you need to have another setup of cluster, another resources. But this existing cluster, whatever created, this cluster still remains lot of resources. So what we can do, we can create the same kind of set of this microservices, 15 microservices as a staging environment in the same cluster, but not on the same namespace. So we'll create a different namespace, and under that namespace, we'll deploy all these 15 microservices inside that one. Okay, inside the new namespace. So whatever the resources was created, the objects was created for these 15 microservices, whether it may be secrets, config maps, volumes, deployments, same you are going to create again, but in the different namespace. So you can give that namespace as a staging namespace. Okay, just a second. Okay, I am back. So this another set of application you can deploy inside the same cluster if these machines have enough resources. If it doesn't have resources, you cannot deploy because if the CPU RAM is occupied by these 15 microservices for these worker nodes, then you cannot deploy. Or else again what you need to do, you need to add more worker nodes to your cluster. If it is an GKE AKS, then automatically they get created with the help of auto scaling concept. But if it is a bare metal QBDM concept, okay, then you need to manually add worker nodes into this cluster. Then you can deploy. Okay, that is the purpose of this namespace. And not only to have different environments also. See, you have single environment only, but you don't want all the resources should be created under the single namespace only. Like for example, this 15 microservices you deployed. For this, you need additional uh, pods or additional applications you want to deploy like EFK and Prometheus, Grafana. You want to deploy. Why? Because EFK is for log aggregation to capture the logs and we can see the logs through the Kibana dashboard. And Prometheus is for metrics monitoring, your CPU, memory, file system. Okay, so this metrics, network utilization, disk utilization, that will be captured by the Prometheus. So we will install this application and we'll monitor. So what in real time, what we recommend in the single namespace, I don't want to see all the parts of my microservices, my applications, and in the same namespace, I don't want to see these parts of Elasticsearch and Prometheus Grafana. I want to separate it. Then what we can do, we can create a separate namespace, and under that namespace, we can able to access like create this EFK related parts. And for Prometheus, we can create uh, so Prometheus something you can give DIT or staging something like this. You can give, and inside that namespace, you can deploy what are the requirements, like apart from parts, what else it is getting created. All the things will be created under this namespace, so that you are separating your application parts or on separate namespace, and your logs and monitoring related stuff you are deploying inside the different namespace. So when you are going to check the resources of specific namespace, so kubectl get all, okay, namespaces if you give, then it will provide the information of that specific namespace. Okay, give the namespace name. So that specific namespace information is going to be provided. By default, let me check whether it's get created. Okay, it got created. By default, when you create cluster, whether kubadium concept or maybe GKE or AKS, you'll have by default namespaces has been created. Now we'll see what are those namespaces by default it get created. The cloud shell is getting created so that we can access that cluster. Yeah, so this is a command we will execute to get, as I said, that config file will be copied into local so that we can able to access the cluster, and kubectl get namespaces. So these are the default namespaces are available. So this is a default namespace, okay, and these are some other namespaces are available. So here, when you create a cluster, some pods gets created related to the components which we discussed in the Kubernetes architecture, the kube proxy and kubelet and API server etcd. Related to that, pods gets created which will maintain those components. All those, it's like, for example, when you install the operating system in Linux operating system, all the OS related stuff will be there, right? In the slash, like usr bin, which is contents of OS related stuff. Same way your cluster related stuff will be available inside this namespace kubectl kube-system. When I type kubectl get pods, any resource, not only pods, okay, anything if you check, okay. So in default, this will go and check in the default namespace. So when you are not giving any namespace, it means it's checking in the default namespace. If you want to check in specific namespace, then -n unity cube hyphen system. So this, they don't want to include Kubernetes cluster software related pods inside the default namespace. That's why they have a separate namespace called cube system, and all these pods get launched inside this namespace. Okay, so you can see kube proxy, kube DNS, some metric server. So these are some default Kubernetes related pods has been created. This is the default, means created namespaces. So here in this article, it has been provided. So what is this each and every namespace? So if you see cube-public namespace for resources that are publicly available, readable by all. And the default catch all namespace for all objects not belong to either of the kube-public or kube-system namespaces. So the default namespace is used to hold the default set of pods, services, and deployments used by the cluster. If you are not telling where to create, then by default will go and create in the default namespace. So when we were practicing to create the pods, if you remember, deployments, whether it may be normal deployment or directly we are creating a pod. So I was not telling where to create in which namespace. So by default, we'll go and create in the default namespace. Okay. So let me create any pod from here. Okay, so I'm going to deploy Nginx with the type kind called deployment. Okay, so with this YAML file, I'm going to create it. So now I'll copy this and I'll go to the shell. So vi nginx deployment.yaml. Why it is not getting copied? I think we need to do something to copy into that console. Why it's not getting cancelled? Open terminal and it is getting the same terminal.
What is the drop down next to that plus sign? Yeah, next to that, yeah. Okay. It's opening another one, I think. Establishing connection.
Okay, so now what I'll do git clone. This copy paste is not working here. Think we need to do something to copy from the outside. For a case, we don't need to do anything. I'll do one thing. I'll enable my uh, AWS notes. I'll see later on how to like copy the content inside this cloud shell. Okay, so as I said, you can create a namespace. So for single set of applications also, you can create different namespaces, and you can deploy different types of components in different namespace. Okay, so here, but this whatever you configure these microservices to communicate each other, they should be in the same namespace. Okay, if you create 5 of them in one namespace and another 5 of them in different namespace, then they will not connect properly. Okay, so that's why you should create these in the same namespace. And another thing is the names are very very important here. So what are the names you are giving uh, for your namespace? Okay, means for your applications. For example, here we have an deployment. Let's say this is I'm going to deploy nginx deployment. Here I'm giving this deployment name is nginx deployment, right? In the same namespace, again you cannot create the deployment name with the nginx deployment. It will tell already this is exists. But if you create in the different namespace with this name, it will create in a different namespace, but it cannot create in the same namespace with this name. So this is kind is deployment. Here kind means lot of objects will come, whether it's a config map, volumes, or any secrets, okay, service. So all these things, what are the name you are giving to that, with the same name in the same namespace you cannot create. So you need to give different names, but with the same name you can create in the different namespace. And if you are configuring, if you are creating anything through the YAML files, then here you are going to give the namespace below this name. We are going to give the namespace equal to the namespace name. It means we are telling this should be created under this specific namespace. Okay, so if you check kubectl get namespace, so here I created these namespaces, but by default you don't see this namespace. Okay, only you'll see cube node lease public, and we'll see what are the components are available inside this get all hyphen n cube hyphen public. I want to see all the components of this. Nothing is available, and cube get all hyphen n and cube hyphen system. So these are the components has been created inside this cube system namespace. These are the pods, right? And these are the services got created. The topic which we are going to discuss now after finishing this namespace. And this is a daemon set. We already discussed. Okay, daemon set. And this is a deployments. So the types of deploying the applications we discussed: replica set, replication controller, stateful set, daemon set, and deployment. So here, if it is deployed, daemon set means what? Already we discussed. Means it expecting each and the pod should be created in each and every worker node. So if you see, this is for Calico pod. So when we deploy this application through KubeADM, so it is expecting whatever the worker node it is having, each and every worker node, the Calico pod should go and create. And if new worker node has been added, automatically daemon set responsibility to deploy that pod inside the new worker node, because this is networking. So that's why all the worker nodes should be in that network. That's why this Calico, when I deployed the YAML file, it is configured with the daemon set deployment. That's why we can see daemon set. Okay, so instead of looking each individual resource, you can get it all information with kubectl get all, and this is for kube proxy, and remaining all are normal deployments, like we discussed. The last deployment type was deployment. So if you deploy any application with stateful set, then that is also it will show all the resources. So as of now, these are the resources has been created inside this cube system. Okay, now if I check cube system get all, I'm not giving any namespace here, so it will take by default namespace. So these pods are got created, and these are different pods compared to these pods. Okay, so these are the pods. Nginx deployment is running here, and these many services has been created for different services, and this is a deployment, and these are the replica sets. Okay, and this is a job is also running for this one. Now this many resources has been created. So all the resources we can check of that particular namespace. Now let me take any, let's say this is a deploy. So this is one of the deployment of Nginx deployment. So this we can deploy inside the uh, specific namespace. So what we can do, I'll edit this. So below this, below metadata, namespace, Nginx something namespace we can give, and then I will create it. kubectl create -f. But this namespace should be already available when you are defining in the YAML file, that you are telling it to go and create this deployment on this namespace. But if it is not available, then it cannot able to create it. So you should create it manually by default. But still, I'll try to create it. See what it is telling? Error not found. When creating deployment.yaml, namespace nginx not found. It doesn't have. It will not create by default. So it should already there. Then only this deployment will go and create the resource inside the namespace. So let me create it. kubectl create namespace and this namespace. Okay, it's done. Now again, if I execute the same command to create this deployment, it got created. Now if you want to check kubectl get pods, here you can't see that because when I'm typing kubectl get pods, it is referring to the default namespace. So when you check kubectl get pods -n nginx -dev, here they got created 21 seconds ago. It got created. Okay, so that is the purpose of this namespaces, so that you can create resources in different namespaces. Okay, but few resources will not belongs to any namespace. Those are volumes and nodes. If I check kubectl get nodes, nodes will be not belong to any namespace. Okay, and kubectl get pv volumes also. Okay, so volumes will also be not belongs to any of the um, namespace, but remaining all these are belongs to the namespaces. Okay, understood?
Sorry, can you repeat that statement, please?
See, we are talking about the resources, right? Kubernetes resources, like services, jobs, mm, pods, deployments, config maps, secrets. These all are the resources. So all these resources will be part of some namespace when you create it. But when you create volumes, when you're adding the nodes, these two will be not belong to any of the namespace. It's like a global namespace.
So the following will not be in any of the namespaces, either by either default or any other created namespaces.
Sorry?
I said the volume will not be in any of the namespaces.
Yes.
All right.
Praveen,
Okay. Yeah.
how can we apply these network policies like firewall on this namespace?
What kind of network policies?
Uh, like firewall policies?
See, here internally you are not applying any firewall policies. If you are talking about Nginx or maybe Istio, that will be separate. Okay, so the resources whatever you are using, now we'll talk about the services. Once we complete the services, then you might understand, okay, about what you are like thinking about the firewall rules or whatever it may be. See, we don't configure firewalls here. We'll just configure service to access this application from the external world. Okay, so will be configured firewalls, anything will be under the load balancer, or maybe if you're having a Nginx ingress controller or maybe Istio service mesh, there you are going to configure everything, because from external world traffic is coming to that service mesh or Nginx ingress controller. From there, the traffic will send to the internal. So internal, no need of any firewalls here. Okay. So I hope you understood. Yep.
Praveen, so where do
Yep.
these namespace gets created? Is it inside a node or where?
This is inside the cluster. It will get created.
Okay, so it is outside the node basically. If I'm not wrong, true?
Outside the node, in the sense, in the Kubernetes cluster software, it will get created.
Oh, okay,
See,
okay, okay.
outside the node means where is your cluster is running on your nodes itself, right?
Nodes. Yeah.
Yeah, after that it will get created.
Fine, understood.
So why we are creating here separate Grafana namespace, and why we have Prometheus namespace, EFK log. If you see kubectl, as of now I deleted all the resources. Kubectl get nothing has been there. Only services has been left. So when I want to go and check Elasticsearch related stuff, I'll go and see in the EFK log. If I want to go and see the Prometheus related stuff, I'll go and see inside the Prometheus namespace, so that all the stuff whatever has been created, so it will be inside the Prometheus. So if everything under the default namespace, then it will be full of messy, because all the resources will be in the same namespace. So when you type kubectl get pods, it will show your application pods, it will show your EFK pods, and it will show Prometheus, Grafana pods all together. So instead of that, we can separate them, we can deploy them in the separate namespace, so that whenever we want, we can go and check in the separate namespace also. That way you can use, as I said, if you want to deploy multiple environments inside your organization, then dev environment, staging environment, that is also possible. But mostly we don't prefer. But if you are having a budget problem, you don't want to create another cluster, so in the same cluster you want to manage it, then you can create another namespace and all the necessary things again you can deploy. So again, there also, for this 15 microservices, this dev, you are not going to create all this EFK Prometheus Grafana also inside the dev namespace. For this, what you'll give EFK dev, Prometheus dev, Grafana dev namespace will create, and it will belong to this dev. And for staging related microservices, again you'll create EFK stage, Prometheus stage, Grafana stage namespaces, and those will be belongs to this one. Okay. So that's how you can configure your resources inside that. And now we'll talk about the services part. Okay, so
Praveen,
yeah,
for production, we should maintain a separate cluster, right?
yes, the complete new setup will be there with lot
Okay.
of security will be updated inside that.
Yeah, thank you.
Okay, so services, which is very important. So service is an abstraction which defines a logical set of pods. So here, if you go into the Kubernetes documentation, and even for namespace also, if you go to the uh, Kubernetes documentation, then you'll get lot of information. So namespaces are intended for use in environments with many users spread across multiple teams or projects. So working with namespaces, these are the default namespaces which we talked about it. And while you are creating the deployment through command line, if you are see, not only through the YAML files, you can create the pods with the command line also. kubectl run, like how we are using Docker run -it nginx or CentOS image, it will pull the image and will create the container. Same way we can create through the kubectl run command also, same like Docker run command, and the name, and this is the image which we are giving, and -f namespace. In that specific namespace, that container the pod gets created. So I was using the example of one using YAML file. So in the command line, if you're creating, then you should give the namespace here. If it is a YAML file, in the configuration file, you need to give namespace is so and so namespace. Okay. So service, here we have three types of services are available. One is cluster IP, another one is node port, and another one is load balancer. Okay. So these services works with the concept called selectors. Okay. So now why we need these services? Why? Because let's say we deployed application, one of the application, and this application you mentioned three replicas, and these three replicas are deployed on three worker nodes, and each pod is assigned with an IP address. By default, pod range IP range will be separate, and that IP range will be having some IP address. Okay, so here if you see 192.168.1.14, 192.168.1.15, some IPs has been assigned to this pod. So to access this, so kubectl get pods -n nginx-dev, and if you want more information -o wide. So here how we can access, just checking curl http and the pod IP address to check whether it's working fine or not. Yes, nginx page is opening. Okay, and same way for this one also, 103 also same, you can see 103 also same, it's getting open. 1113. Okay, three pods are opening. Okay, this IP is different. Curl. So we are testing from cluster internally. The pages are opening, the Nginx website is working. When assume this is an application, then same way you can test it. But this application should be accessed from the external world, not from the cluster itself. Internally it is accessing, but you cannot give customer to log into the cluster and to execute curl command, right? The purpose of this application should be accessed from the external world. So how it can be accessed the external world? For that purpose, we need to create the service for each application, or each you can call it as a microservice. And here you are mentioning high availability for three. Okay, and these IPs you cannot give three IPs. This is internal pod IPs. This cannot can be accessed from the external world. So how we can access? We have three types: cluster IP, node port, and service load balancer. So first we'll talk about cluster IP. So here, where it is, cluster IP. So cluster IP exposes the service on a cluster internal IP. Choosing this value makes the service only reachable from within the cluster. So this is the default service type. So the first thing cluster IP means, this will not expose to the external world, but internally it will help. In which way? Let's say you have front end pods and back end pods. Assume these are front end pods. These are called as a front end. Front end means web application, and these are back end. Assume these are database. MySQL database has been deployed as a pods. Now this application needs backend database should be connected. Then how it will be connected? They cannot give these pods IPs inside this front end application so that it can communicate. They can give, but which IP will they will give? And these pods are not immortal. Okay, anytime they can delete. Again, new pod will get the new IP. If you check here, um, I'll delete one pod. kubectl delete pod and -n nginx -dev. So I'm giving the namespace. So sometimes we'll forget to give the namespace. Then it will tell this pod is not present in the default namespace. Okay. So when you are seeing information with -n nginx, then for deleting also you should give the full namespace. Now if you see get pods, new pod has been created, and if you see the IP 24 seconds 70 IP 89.70. So IP is getting changed. So you cannot give the IP here. It's not permanent IP here. Then how these applications will connect to this backend? So in this scenario, internally, you can create a service called cluster IP. So this will help you in this cluster IP. These pods will be configured. Okay. Now this cluster IP you are going to configure inside the front end application so that it will connect to the cluster IP, and this will route the traffic to this specific pods. So how cluster IP knows that which pod it should send the traffic, and when new pod gets created, how cluster IP knows that new pod gets created. Okay. So here if you see for this is the service. So the kind is service. The important section for the service is called selector. We already discussed previously also selector. So if you see selector in the deployment, when you are deploying an application, there you are going to give a selector name. That selector you are going to define inside the service that okay, this is a selector. Okay, then it will go and connect with that application. If the selector is not matching, then it service will be created, but it will not point to the application. Okay, so main important is selector. If you see here, okay, so I did not mention here any cluster IP here. By default, it means it's a cluster IP concept. And if you see, this is the name of this my service. And if you see, labels is nginx-app, and selector if you see app nginx-app. Okay. So now here main important in this service is selector, means any deployment pods which got created with label name equal to nginx-app, then it will be pointed to that specific pods. So if I go back, nginx-app, right, and nginx deployment. So if you see here, for this is a deployment and this is an app. Okay, I will show you practically how we can already we deployed this application, right, with the same deployment file. I think so. kubectl describe pod. Let me confirm whether this contains same -n nginx-dev. Okay, this is different. If you see labels equal to nginx is there, not nginx-app is there. Okay, so if you see nginx app equal to nginx. So now what I'm going to do, I will take this service. I'll remove here from nginx-app to nginx. Okay, not this one. Where is the service? Nginx-service. Now vi nginx-service.yaml, and here I'll change the label name only nginx. Okay, this is a service is getting created. So I'm saving this file, and if you check kubectl get svc for service, the object name is svc hyphen n nginx hyphen dev. In this namespace, there is no services has been configured. But if you check kubectl get svc in the default namespace, you can see few services has been configured. If you see here, if you create cluster IP, you can see this is the cluster IP. Okay, and if you configure node port, this will be the node port. If you configure load balance, these are the three services we are going to talk about. As of now, I'll tell about cluster IP, and tomorrow we'll discuss about node port and load balancer. So now I created this file called nginx-service, and but I did not mention the namespace. So let me mention the namespace here in the metadata section. Above the name or below the name, wherever you want, you can give namespace nginx-dev. So inside that it should go and create, because application pods also got created over there in that namespace. So for that application, we are configuring this one. Okay, sorry, this is a type is node port. So here we have only single port, and here selector we are giving only nginx, and I'll give namespace nginx-dev. So inside this it should get created. Okay, now save this and create it kubectl create -f nginx-service. Now if you check kubectl get svc-n nginx-dev, the service port, this has been created. Okay, then how to confirm whether this is pointing to that application? Okay, for that you need to kubectl describe svc and this service name, what are the name it has been created. Okay, see, if I'm not giving namespace, it is telling not found, because it will check in the default namespace nginx-dev. These are important endpoints. Okay, whenever you configuring, even when I was initial days when I was working on the Kubernetes cluster, I was configured application and I configured service, but I cannot able to access the application with the service IP, whatever I created, not cluster IP, anything. So why? Because I was giving a wrong selector name. Okay, so like for example, this is a SaaS, and I was giving like for example platform as a service. So I was giving this is a mistake. So in the deployment file, I gave PAAS as a name, okay, selector name. But in the service file, I was given PASS. So it did not find any application. Service gets created and deployment is created. But when you're trying to access it, backend it did not find any application with that selector. So there is no endpoint has been created. If you remember, while we're talking about Kubernetes components, I told control manager. Okay, so node controller will be there, replication controller will be there, endpoint controller. So endpoint means these are called endpoints will be created. So that this the endpoint controller responsibility to maintain these endpoints. So what are these pods? These are what is this IP? These are the IPs of pods. If you clearly see kubectl uh, get pods -n nginx -dev -o wide. Okay, so these are the pods IPs 103, 113, 70. So with the help of this service, so service even if new pod deleted, then again what I'll do kubectl delete pod, and I'll delete one of the -nginx-dev. Then automatically it will come to know to the service. Why? Because new pod, whatever it gets created, it will get created with the same selector name, the label. So again it will pick up. Okay, new pod has been created with 95, and here there is no endpoint, right? Previously with 95p, then again we'll try to check that. Now you can see 95. This is how the cluster IP service will recognize here mainly with the selector. The important concept is selector. If you do any mistake in selector, the name spelling mistake in the name this selector, whatever the selector you have given for the label name you have given for this application, the same it should be available here. Then only it will find out. Okay, so this is for internal. As I said, cluster IP is not to access from the external. kubectl get pods -n sorry, get svc-n nginx-dev. So curl http nine okay, so it's taking time. So this is for internal. From in this front end, then we'll configure this cluster related IP so that it can connect to this cluster IP, and then it will send the traffic to this internal pods. So this is for internal communication. So tomorrow we'll talk about what is node port and what is load balancer. Okay, if you have any doubts, you can ask me, or else we'll wind up for today's session.
How can we give this port mapping between cluster IP and pods?
Cluster IP
And pods.
port mapping means what you want to do?
Suppose I want to use for pods port 80 and for cluster IP like port 8080.
That you need to define inside this service. So what are the service we are creating here?
Okay.
nginx-service. So here we need to give that port. So whatever the internal port is there and what the external port you want to map, that you can give.
Okay. Is there any order like for creation, like we have to create pod first and then service later?
Not an issue. You can create basically one by one slowly we'll come to the Helm charts, right? So in the Helm charts, all together will be one single Helm chart, like you config maps. As of now, we are going to create individually the requirements, but in the coming sessions when we talk about Helm charts, in the Helm chart, it will be all together in a single Helm chart. For example, volume or config maps, secrets, service for that application and that application all together will be in a single Helm chart. So when you deploy, it will take and automatically it will create in an order.
Thanks, Praveen.